sponsored by Bamboo Lab. This is a giant RC cargo plane I made to see if it would fly. It's one of the weirdest looking aircraft I've ever built, and certainly looks like it should never get off the ground. It's based off an aircraft called the Super Guppy, one of the strangest planes to ever take to the skies. The Super Guppy was built by NASA and has a massive bulbous hump on the top for its cargo that makes it look more blimp than plane. But somehow it still flies, carrying massive amounts of cargo all across the United States. Ever since I first saw a cargo plane like this one fly overhead, I've wanted to have a go at building my own, as it seems like one of the ultimate model aircraft challenges. And the first thing I had to do was figure out if an RC version of the Super Guppy would actually fly. The oversized cargo fairing creates a huge amount of drag, and that might not scale very well on a model RC plane. So to figure this out, I've come up with a step-by-step experiment, and I've used my brand new Bamboo Lab H2D 3D printer to create some small models to demonstrate my plan. And yes, you might have noticed that these 3D prints are printed in multiple colours, and that's thanks to the dual nozzle system on the H2D, which improves print speed with multicolour prints while also reducing wasted filament. Step 1, I'll build a simple 1 meter wingspan prototype RC plane and test fly it as a benchmark. Step 2, I'll add a small cargo fairing, a scaled down version of the Guppy's bulbous hump, to see how that affects the flight characteristics. And then finally, step 3, I'll push it further by fitting a much larger fairing, closer in proportion to the final design, and test that too. If all of this goes well, then I'll have confidence to build the giant RC cargo plane with a 3 meter wingspan. Firstly though, let's build that prototype. I started by choosing a material for the airframe. I went with some good old-fashioned 5mm foam board, lightweight, easy to cut, and perfect for quick builds like this one. I folded it into a box section to form the fuselage, and then cut the tapered tail and curved nose. To keep things strong but lightweight, I added bulkheads inside and then sealed the top and bottom with some more foam board. Next up, the wings. Again, these were made from more foam board, folded and cut to form a basic airfoil shape. I reinforced the wing with a carbon spar from my material sponsor, Easy Composites, link in the description, and glued everything together. Super simple. Now the tricky bit was fitting the wing to the fuselage at the right angle of attack. Next, the electronics. I chose a couple of compact brushless motors, perfect for this scale, and gave them a quick test on the bench before mounting them to the 2 foam motor nacelles. The real Super Guppy had 4 engines, but this little prototype would only fit 2. Hopefully they would produce enough power for the immense amount of drag. The prototype was now nearing completion, so it was time to turn attention to the payload fairing. Importantly, these fairings on cargo planes have to be as streamlined as possible to minimize their immense amount of drag, and our fairings would need to be no different. They would have to be as smooth as possible. So I used the Bamboo Labs H2D to quickly print out some fairings for the prototype plane with its very useful 350 by 320 by 325mm build volume. The H2D made quick work of printing 2 fairings, which I then attached to the front of some more foam board. Now we had 2 hilariously oversized modules ready to test, and I was dying to find out whether the plane would fly with either of them bolted to the fuselage. Okay, so we're going to fly the plane as is to start with, and then we're going to pop this module on, which is the smaller of the 2. We'll see if it's too draggy or there's too much of a crosswind to fly. It's very windy today. And then we're going to put this one, which is the second module. If it can fly with this massive thing on it, then I'll be fairly confident in our giant scale cargo plane. First up, the plane on its own. How would the basic airframe perform? Okay, run. Wow, that's smooth. It works as a normal non-cargo plane. I'll just get it trimmed out a bit. The plane flew well. It seemed like it was a good design to base the cargo plane on. Now to bring the plane in safely for a landing to progress to the next part of the experiment. Hey, it survived the wind. Time to glue on the first of the 2 fairings. This one would roughly double the size of the fuselage, so would the plane still fly? Okay. Always struggling a bit to climb, but it's working. There we go. That looks like a cargo plane to me. Oh, it looks so weird. The crosswind was affecting the plane, but I was able to fly around it. Not unlike the real Super Guppy, the plane wasn't exactly graceful, but it was getting the job done. Just keeping the power on. I think it needs quite a lot of power. But yeah, that's working pretty well. Look at how smooth that is. Doesn't like the gusts of wind. I'm going to land it over there. Most unglamorous landing ever. Let's go and put the number 2 size module on the top and see how that one works. This second and final fairing was fitted securely to the airframe, and the plane was now ready to fly again, but this time with a fuselage of around 400% of the original size. I had a sneaking suspicion that this was going to be the one that pushed things a bit too far. Ready? Trucks away! Oh my goodness, a lot of concentration is needed this time. The plane didn't seem to have enough thrust to overcome the drag of the massive payload fairing. Oh, it's not really liking that payload. Oh, oh no. I think that was a bit much for it. Let's have another go. Uh-oh, there's the wall. I'm over the wall. Nice to land it. Yep, the plane definitely didn't have enough thrust. The payload fairing was now too large and too draggy. Yeah, I think we've found the limit here, so this is a bit too big. There's a bit too much drag on it. And that was meaning that we needed a bit more thrust. So I think somewhere between this and the previous number 1 module is where we should aim for on the giant scale RC cargo plane. So let's get back to base and yeah, design this giant one. With the lessons from the prototype under my belt, a design for the much larger aircraft came together over the next couple of days. I was feeling confident. Based on what we'd learned, I reckoned that we'd have a solid aircraft that would fly if we built it upon the lessons learned from the prototype. One that would make for a seriously impressive RC cargo plane, but I'd only know if we'd got it right on the maiden flight. But there was a big problem with building a big aircraft like this one. We need to figure out how to get it to a suitable flying site. Our usual ProjectAir test field, the same that we'd used on the solar powered plane project and the Corsair dive bomber project, just wouldn't quite cut it for this giant RC aircraft. I found this out the hard way during a less than successful test of the giant Magnus Effect plane from a couple of videos ago, which now needs some fairly major rebuilding. Well, that's our first tree strike in a while. Clearly, we'd have to transport the plane to a larger RC flying field, suitable for giant RC planes. And to do that, I'd need to fit it inside a van. 2 meters, basically. This all meant that the plane had to be modular. So we're probably going to have to make the wings detachable and also the fuselage in half. I don't know, we'll figure it out. This would complicate things and bring in its own challenges. Once again, we would build the plane from foam board and carbon fibre, which would be used to build a super strong but lightweight monocoque structure. But this would take a lot of foam board and a good bit of reinforcement inside to make it strong enough to hold its own weight. I'd also need a few plywood parts to reinforce key areas of the plane. And to make these, I'd use the H2D. But if you're confused about how I'd use a 3D printer to make wooden parts, you'll have to wait and see. Once the fuselage was glued together, it could barely fit on the workbench. And this was before adding the wings or the massive fairing. The wings were up next, and these were formed by joining several foam board sheets together before cutting them to shape. These had to be much stronger than the prototypes, so I added 2 carbon tubes as reinforcements. Each wing had 2 carbon tubes, which would slot inside larger diameter tubes inside the fuselage of the aeroplane, and this would be part of the modular assembly system. Everything had to be carefully aligned and fitted perfectly. After a fair amount of hot glue and a couple of hours, the wings were just about done and looking pretty good. Now to fit them to the fuselage. But of course, the carbon tubes inside the fuselage couldn't just be glued straight to the foam, as they'd probably rip straight through it. Instead, they'd need a proper wooden structure known as a wing box to distribute the load. Now this was a bit of a problem, as I'd need to make sure that these tubes lined up perfectly with super accurate wooden parts. But thankfully, I could cut these parts on my new laser cutter, which also happens to be the Bamboo Labs H2D. As the really cool thing about it is that it's not just a 3D printer. It's a full-on personal manufacturing hub. So we just need to swap to the laser cutting 10-watt module and then we can, yeah, start laser cutting these plywood parts. Cut them all out very precisely, much more precisely than if I was doing this by hand, and yeah, then we'll have the wing box done. Everything the Bambu Labs H2D does, it does really well, and I can see this thing being used for years to come in the ProjectAir workshop. The H2D is all about multifunctionality. Precision! You've got 3D printing, laser engraving and cutting, and digital cutting all in one machine. Now with all of the wooden parts cut, I could build the strong carbon tubes into the wing box, and this part could now be installed into the aircraft. There we go. Nice! We have a plane! This is where it all feels like it's actually come together. This only took about a week to get to here. Now to convert the H2D to be a 3D printer again, by simply removing the laser module and replacing the bed. Now I could start printing the giant fairing front that would be a massive part made up of 5 separate sections. For these large overhanging parts, I'd need to use some supports. And this is where the dual nozzles really come into their own. Bambu Lab actually sent me some of their PLA support material to try out, which breaks away really nicely from the finished parts, leaving no surface defects. To print this separate support material, I loaded it into the Bambu Labs AMS HT, which, like the AMS 2 Pro, comes with built-in drying features, which is very important for printing this material. I then loaded the standard white PLA into my AMS 2 Pro, placed on top of the H2D, and got the giant parts printing in no time. The new AMS 2 Pro is actually also compatible with the X1 and P1 line of Bambu Lab printers, so it actually works with the Bambu Lab P1S I already had, which is obviously really helpful. In no time I had all 5 of these giant parts printed out, the supports cleanly broken away with zero evidence of them having been there, and all of these parts were then assembled into the finished fairing. And all of this only took a few hours per print thanks to the rapid speed of the H2D. The dual nozzles really helped speed up the printing of 2 materials here, and allowed for really quick print times with excellent smooth results, thanks to the special support material. With the fairing print complete and glued together, the rest of the payload module can now be put together with some more foam board. And now the plane was really starting to come together and take on that familiar, crazy Super Guppy shape. It was all looking pretty massive. I ended up cutting out all sorts of parts for this project on the laser cutter inside the H2D, from motor mount plates to the all-important control horns. And these were all made from 3mm birch ply, which is not actually that easy to cut. It's been so helpful to have a desktop all-in-one machine that's actually in the workshop, and it's really sped up this whole project massively. The main parts of the build were now done, but we still needed to do the electronics. How were we going to power such a gigantic RC aircraft with so much drag? The answer is to use as many motors as possible to get the most thrust possible. I decided to combine 8 brushless motors, each spinning a 10-inch propeller spaced out along the wing, and together they generate around 5 kilograms of thrust, which fingers crossed would be enough to get this beast off the ground. If NASA had the Super Guppy, then this ProjectAir monstrosity would have to be named the Ultra Guppy. Each pod had its own battery to keep the wiring simple, and each side of the plane could be run independently using differential thrust. This would help me to steer the behemoth through the air without relying too much on the rudder. Next, I needed to solve another problem, which was to make the plane a bit more visible in the air. So out came the silver spray paint again, just to do a light coat to give our new plane a bit of that NASA-inspired finish.
Ooh.
I hope this isn't getting paint on my overalls. I've only got one pair of these that are nice still. Now, how would we make this plane take off and land? The plane would need an undercarriage strong enough to hold all of that weight, so I opted to build the landing gear using some large foam-tired wheels and some seriously chunky 12mm plywood struts, as sometimes you've just got to over-engineer it. With a single nose wheel fitted to some strong foam under the nose, the plane was now pretty much finished and ready for its first trip outside, but not before some decoration in the form of some ProjectAir logos cut on the Bambu Labs H2D with the vinyl plotter module. Yes, that's right, this 3D printer is also a vinyl cutter, which is super convenient at this stage of a project like this one. With the digital cutter in place and a special build board installed, the ProjectAir logo could be quickly cut out with some black vinyl before being transferred to the fin of the aeroplane. Looking good is an important design consideration, of course. Yeah, very professional.
Yeah.
Now it was time for the plane's first trip outside for a test run. Everything went together really easily and the mighty aircraft was soon looking the part. With its 8 batteries installed, now it was time to see how much power this thing had. It was certainly pulling. The only issue I found was the propellers were a little close to the ground for comfort. Hopefully this wouldn't be an issue at the grass field. Subtle foreshadowing there.
Right, let's get it loaded up.
With the plane packed up into its modular form on board the ProjectAir Forward Operating Base Vehicle, otherwise known as the van, we had everything ready for the next day's maiden flight. I'd need to take a lot of spares just in case the plane got damaged and needed repairing, just to be prepared for anything. I also took the opportunity to print some multicoloured lens caps for my GoPros that I thought were very on brand, using a colourful multicoloured model found on MakerWorld. With just one click, I had it printing on H2D and in about 20 minutes it was done. Nice, now we were ready. The next day we headed off to the British Model Flyers Association National Centre, and despite the smiles, nerves were running high. The weather conditions were looking good, but when we got to the airfield, it turned out that we had a bit of a problem, and that was there was a crosswind.
Gently does it. So I'm a bit worried about the wind. It's not that breezy at all, it's probably like 7 or 8 miles an hour, but the prototype definitely suffered from crosswinds with its huge fuselage. So yeah, it's going to be interesting with this massive fuselage, how that will perform in the air and how that will survive being blown around. Yeah, I'm feeling very nervous about the flight, more so than usual. I know I do a lot of these projects that are quite experimental, but this one is quite a big one in terms of, yeah, if it goes in, it's going to make quite a big mess. If some small thing goes wrong, if the elevator comes off or I don't know, some connection goes loose in the fuselage, then yeah, the whole project might get destroyed in a matter of seconds. So I just need to focus the best I can, put my best test pilot pants on and go for that flight. So let's see what happens.
But now we found another problem. The plane was tail heavy, and if this remained the case, it would almost certainly crash, as it would become uncontrollable in the air. So this was definitely a time to err on the side of caution by adding more mass than we thought we needed to the nose. 3 big LiPo batteries would probably do. We were nearly ready to go, but then I discovered potentially the biggest hurdle so far on this project, which might mean we'd have to cancel the test flight completely.
Ready?
Yep.
The outer propellers were dipping too low and striking the grass.
God, I hope the runway's smoother.
This was all quite worrying. We hadn't seen this issue on the concrete outside the ProjectAir workshop, but on this uneven grass runway, it had now become very apparent.
I think it might be alright now. I'll test it again here.
Yeah, give it a little taxi and see.
We already had 3 major problems to contend with: the wind, the centre of gravity, and the propellers. It wasn't looking good. With the propeller issue, I devised a plan. I might be able to keep the wings level with air going over them, using the ailerons, but I'd only find out for sure when opening up the throttle to full. Clearly, we were going to have to go for it. Experimental aerospace engineering is always a constant process of problems and solutions. The one certainty is, at some point, with every project, you have to make a call whether to go for it or not. And on this occasion, I wasn't going to let a few unknowns prevent us from seeing whether this thing would fly.
This clip might end with me in tears.
I had a plan and knew what to do, so it was go time.
It's definitely rolling, got the audio.
Mike's working, and I'm rolling.
Let's go. All that hard work, let's see what happens. Can we even get off the ground? Okay, powering up.
Yeah, go on.
Very nose heavy. It's going all right, full throttle though. Coming round.
The plane was airborne. The first mission objective was complete.
Just going to keep it going around in a nice flat circle. We're on full throttle and quite a lot of back stick. And we've got 1 circuit complete.
The big plane roared by, climbing slow and steady just like the real Super Guppy. Thankfully, the crosswind was hardly affecting it, but then I thought I heard a noise, as if the throttle was dipping.
Right, I'm not going to talk because I'm concentrating so much.
I'd been running the plane at full throttle, as it only just had enough thrust to overcome the drag of the giant cargo fairing. Were the motors overheating? This could be a real problem. With the plane remaining in the air, it became apparent that the motors were fine, and the noise had simply been the Doppler effect as the plane moved away. So that was a relief. The plane was performing beautifully, but I didn't want to risk flying it for too long.
I'm going to land it, if I can.
But could I stick the landing with that crosswind?
Watch out. Yes! We got it! Oh.
I got it down in one piece. The motors had held up beautifully, even running flat out for the entire flight.
I was pulling up on the stick and it was so nose heavy. So all of that battery weight in the front, absolutely pointless. It would fly really nicely without it. I am absolutely shaking. Like my hands, that was one of the most stressful test flights I've ever done.
So we'd actually done it. We'd taken one of the most bizarre aircraft designs ever to grace the skies and built a homemade giant RC version from scratch and made it fly. And through all of this, we'd proved something quite cool. Just because something looks like it shouldn't fly doesn't mean it can't.
Now, if you're into engineering and this kind of content on YouTube, then you should definitely subscribe to the ProjectAir channel down below. And also, let me know what kind of projects you want to see next on the channel. Thanks very much for watching this video, and thanks to Bamboo Lab for sponsoring it. There's a link down there to get your own H2D 3D printer. So yeah, check that out. And in the meantime, while you're waiting for another video on the channel to come out, then watch this one next. Yeah, I think you'll enjoy it if you've got to the end of this video. So thanks for watching, and I'll see you on that one. Cheerio.
Almost lost the glasses.